In this lesson, we're going to discuss voltage as it relates to electric circuits. Electrical energy is carried through a circuit by electrons. The energy each electron has is called electric potential energy. The change in electric potential energy per coulomb of charge is called electric potential difference and is measured in volts. Because the differences are measured in volts, electric potential difference is often simply called voltage. Voltage is what causes charges to move in a circuit. To understand how, it's useful to think of a waterfall. The water in a waterfall naturally flows from a higher point to a lower point. Similarly, charges naturally move from a higher level of energy to a lower level of energy. That difference in energy and potential energy between one point in a circuit and another makes charges move in a circuit. This difference is called voltage. The volt can be defined mathematically as 1 joule per coulomb. We can use the formula V equals delta E over Q, where V is the voltage in volts, delta E is the change in energy in joules, and Q is the charge in coulombs. The letter V is used as a symbol for both voltage, the electrical property, and volt, which is the SI unit of measurement for voltage. To distinguish between the two, we'll often italicize the V for voltage in the formula. How do we measure voltage? We can measure voltage using two devices. The most common one to measure voltage directly is called a voltmeter. Voltmeters can be connected to the energy source or the load in a circuit. In a circuit diagram, we recognize a voltmeter by the letter V with a circle. We can also use multimeters to measure voltage, and this is done more commonly in household applications. Both voltmeters and multimeters may be analog or digital. At EMCS, we commonly use analog voltmeters to measure voltage. We can also use multimeters, which are a very handy device that can also measure current and resistance, and your parents may have these at home. How do you connect a voltmeter? It's important to connect voltmeters in parallel across the energy source or the load. The diagram on the right shows how we would connect a voltmeter to measure the voltage across a light bulb. When cells are connected in series, the sum of the voltage of the combined electric cells equals the sum of the individual cells. In other words, we simply add the voltages of the individual cells to find the total voltage of the battery. When cells are connected in parallel, it does not provide more voltage, but they do provide more charge. In addition, cells connected in parallel can either provide greater current or longer battery life. Cells may also be connected in a combination of series and parallel, as in the diagram below. Looking at the diagram, we can determine the final voltage or the total voltage of the battery by determining which part is a series or cells in series and which part are cells in parallel. The voltage of the cells in parallel, the top part of the diagram, is 3 volts. So each branch shows two 1.5 volt cells, giving each branch a voltage of 3 volts. Since voltage of cells in parallel is the same, we know that the top part is responsible for 3 volts of electric potential difference, and the bottom is another 3 volts. When we add them together, we get a total voltage of the battery of 6 volts.